All right, now I want to talk about how we actually compare a bunch of different alternative models. So far, if you've been watching these videos in order, we've been going through a series of regression models and then classification models, and we were comparing R-squareds and RMSEs with the regression models. We're comparing accuracy and precision with the classification. Well, that's great for comparing the exact same set of features or variables. What if we want to mix up the variables next and then see what happens along the same algorithm? So I'm going to use this last one that the last video I finished was the neural network two-class bike buyers example. Let's remember, let's go back to that one. Notice here, evaluate model has two inputs. So you can probably guess what that's for. Let's move this over, and I'm going to start a whole other model using the same data set. I'm going to grab another select columns, and I'm also going to connect this from the same bike buyers data. Now the difference in this select columns, if you remember back when we first started all this, we were learning in Excel how to create dummy codes, but before we could learn dummy codes, we changed a bunch of our categorical variables to numeric variables. Education came in the form of partial high school, partial college, bachelor's, and graduate. So we changed that to 1, 2, 3, 4, 5, an ordinal, a rank ordered variable in the order of amount of education. Well, then we went back to treating education as a categorical variable, and we tested dummy codes. We found that treating education as categorical and using dummy codes, which ignore all ordering or ranking among education types, gave us a better R-squared value. Well, now we're into classification models where we're not looking at R-squared, we're looking at accuracy and precision. What I want to do is once again compare using education as a rank ordinal variable versus a categorical variable. Now, in this model we've been using all along, right here, we've been using the education categorical version that has that text, partial high school, graduate, and so forth. So let's make another model and compare it to that one where we treat education, whoops, wrong one. There we go. Where we treat education once again as a rank ordered variable. And put that one in the model instead, and let's grab everything else so we can treat them exactly the same. And oh, don't forget region and purchase bike are dependent variable. So I'm using the classification model here because purchase bike is a yes/no value, not a 0/1 value. Anyway, let's go ahead and normalize just like we did before. Make everything perfectly comparable. We're just going to take the default, normalize all numeric columns. Great. Once again, we need another split data. Let's pull that one in. There we go. Split data, we need a train model. Now, to use this feature, know that we have to use the exact same algorithm that we used on the other side. So this is a two-class neural network. We also need a two-class neural network. There we go. Let's stick this over here somewhere, connect into the train model over here on this side. All right, this is getting kind of messy, I know. Our split, let's make sure it's comparable. So just like this split, this one needs to also be a 0.7 with the same random seed. Or at least to make them comparable, we should do that. We don't technically have to, but we should. Train model, once again, we are predicting purchase bike right here. Okay, let's grab, if we're going to evaluate, we're also going to need to score the model. So it's going to need its own score model from there to there, bring in the split data. But now we can drop the score model into this evaluate model and look at them both together. So let's go ahead and run that. I'll pause this while that's running. So there's nothing too magic about this other than this one feature that I like. So now we have the score data set of the original, and this is the score data set to compare is the one that plugs in on the right-hand side of the model that we just made. So here's our original. Remember, the more area between this curve and this line of random guess, the better. So what it shows us is that there's actually points at which it's more accurate to predict based on the rank ordering of education. In particular, when we get here past looks like the 37% point, the numeric version or ordinal version of education is a better prediction. So click here on score data set, and let's see, our accuracy was 670. Click now here on the numeric version of education. We've gone down to 657 overall, but there's points at which it's better, and that's what we want to know. If we're going to go after, if we want the biggest bang for our buck, so to speak, we want to identify the percentage of people where the difference between the curve and the line is the highest, which is actually right here. So to get the most bang for my buck, if I'm going to go and make a personal sales pitch to a portion of these 1,000 people that are most likely to want to purchase a bike, I want to go to this point right here, 45%. I want to score the data sets, sort them by the probability, and go after the first 45% to get the most money without having to go after the entire population. Anyway, that's how we use the evaluation results to compare two models with different variables.